Another thing we can measure with 3D figures is volume, which is the capacity or amount of space that's occupied by a 3D figure. So how much room is it taking up? Or how much can it hold if we were to put something inside of it? Now let's review something about units. When we have just length like this is a one-dimensional thing, and it might be 1 unit long, maybe like an inch or a centimeter. But when we have an area, as we've been practicing, we are saying that it's a unit by another unit. In other words, it's two-dimensional. It's got length and width. And so the area there is considered square units because they're formed by squares. And then when we come to volume, we need to recognize with 3 dimensions, we're measuring something that is a unit long and maybe a unit wide and also a unit high. And so those are the 3 dimensions, the length, the width, and the height. All together multiplied, we get our cubic units. So units will be cubed here. For example, we might have cubic inches or cubic feet, cubic centimeters, and so on. Keep that in mind as you do these problems. Now this lesson is about prisms, so let's take a look at the area of a prism. It's a pretty straightforward formula. All you do is find what the base area is, not around it, that's perimeter, but all inside of it. How much base area do we have? And then multiply that by the height of your prism. So on this triangular prism, it would be this base area here multiplied by this height over to the other base. So our simplified form of this is the volume is equal to the base area times the height of the prism. Let's see how it works with this example. Now we're going to run through the exact same steps that we have in our other lessons. First of all, what is this? I see that it's got a triangular base, so I'm going to call this a triangular prism. And while I'm at it, I'm going to note the height of the prism is this distance between the 2 bases of 3 inches. And here's my base. All right, so our formula that we're going to need is the volume formula, which is our base area times the height. And now let's analyze that base as we look at the area. Did you notice that it was a right triangle? I hope you saw this right angle here. So it's a right triangle, and the 2 legs are 8 inches and 6 inches. And I am not going to do this to scale. And how long is the hypotenuse? We pull that up from the side there. That's 10 inches on the hypotenuse, or we could have Pythagorean theorem that, I guess. So now we get to calculate its base area. Keeping in mind it's a triangle, I'm going to take half the base times the height. And in this case, my base and height numbers are those 2 legs, the 6 and the 8. So altogether, my base area is 24 square inches. All right, I'm ready to plug it into my formula for volume. So over here, my base area, just figured that out, 24 square inches times the height, which was 3 inches. That comes right from up here. And our final answer is 72 cubic inches of volume. Okay, let's run through those steps again with this one. Now this one, as we identify what it is, I see the trapezoid right in the front, and there's a twin trapezoid in the back, so that makes it a trapezoidal prism, once again. And how tall is this prism? Whoa, get the S in there. Woo! How tall is it? How far from one trapezoid to the other? There's the height right here. So the height is 12 for our prism. And now we're ready to get our formula. For volume of a prism, let's just jot this down. It's the base area times the height. And we will leave some space to plug things in there. Alrighty, step 3. This trapezoid, I'm going to just recopy down here. And note that it's got a base of 20 and one at the top of 10. It's 9 and 10 on the sides, and then right through there, the height of the trapezoid is 8. So let's figure out the base area. We're looking at half of our 2 bases added together times the height of this trapezoid. Plugging in, we're going to get 10 and 20 in there for the bases times the height of 8. So our total for the base area is 120. Now we're ready to finish this off by putting that 120 in the volume formula times by that 12 as our height, and multiplying that all out, we get 1,440, and our cubic units are cubic centimeters here. Oh, this one's an oblique prism. You see that slant on there? This 6.4 centimeters here, that's going to be our height of our prism. But let's start from scratch. All right, so what do we have? We have it looks like I've got a hexagon on there, so I'm going to call this a hexagonal prism. You'll notice there's a hexagon on the bottom and the top. It's got a height of 6.4 centimeters. And so our volume formula, the base area times that height, we just have to figure out back on our hexagon what our base area is. And this is a little bit unique. Usually they make us figure it all out, but look what they gave us. They gave us the base area. They told us all this area here is 17.3. So I'm pretty much just going to write that down and use it as I plug into my formula. So plugging in base area 7.3, height of 6.4, and then just run that through the calculator. And that comes out to 23.7, and then we have our cubic centimeters there. Cool, it looks like with this example we get to change it up a little bit. We're going to find the height. They must have given us the volume. Look here, they gave it to us. We're going to work backwards from the volume. Let's see how our steps work in this case. So what is this prism? Let's count up those sides. 1, 2, 3, 4, 5, 6. It's another hexagonal prism. And the height of this prism is the question. So let's just note that. But let's also write down what formula we can use. Since we were given volume, let's just say we're going to use this volume formula, which is our base area times our height. This height's going to be the mystery. And we can figure out the base area just from the pictures. Now we know a regular hexagon like this one has an area of half of its perimeter times the apothem. Let's see if we can figure those things out. The perimeter, notice that this is a 12 meter on a side, so our perimeter would just be the 6 sides times 12 each. In other words, 72. And the apothem is given to us here as we look at it coming out from the center and hitting that base edge. So plugging in, we have 72 for the perimeter and 10.4, if I can squeeze it in there, for the apothem. And let's multiply that out and get our total base area of 374.4. All right, now we're set to come back over to our formula, and for volume we're going to make a substitution. From our given, the volume is 3,145 cubic meters. From our calculation, we know that the base area is 374.4, and so the height we bring down as our question. You can see what to do. This is some ninjas. We haven't seen them in a little bit. We're going to divide off the 374.4. Both sides. Hiya! And our final answer after dividing is about 8.4. Let me say that's about 8.4 because there's a little bit more to it. And the unit of height on this case would be meters. 8.4 meters tall. All right, that does it for prisms, but what about cylinders? Remember, cylinders are very much like prisms. There's a base area to figure out. There's also a twin base, so there's 2 bases, and then we're going to take the height. And we're going to basically do the same formula, but cylinders are special because that base never changes. So you're going to usually see the base area given as pi r squared. You should recognize that as the area of a circle, and then multiplied by the height. So this is the way it'll appear on formula sheets. Volume is pi r squared times by the height when you deal with cylinders. That makes them easy because we don't have to go through all those steps. We can usually just go straight to our formula and plug in the information we have. So for this one, the volume is going to be pi times the radius squared times the height. Let me put a square on that. Well, what is the radius? That's from center out, so that's going to be 12 as we chop up that 24. Into that spot, and the height we find right there is 14. So let's calculate this, and let's keep it in terms of pi so we stay exact. The numbers multiply out to 2016, and the pi is still in there. And what would be our final unit? These were centimeters, so let's put down cubic centimeters as our volume. And our last example, this one's kind of like the one where we had to find the height. We don't know the radius, but instead they give us the volume. We still go to our formula, pi r squared. times by the height would give us the volume. Let's make some substitutions. In for volume, I'm going to put the 100 pi. On the other side, I'm going to bring down the pi. I'm going to leave the radius squared. I don't know the radius, but I can pull in the 5 as the height, distance across there. First thing I'm going to do is I'm going to divide off, as I try to isolate that radius, I'm going to divide off the pi. I'm going to divide the 5 too. Get all those numbers off of there. So over here on this side, dividing by the exact same thing. Now some ninjas get to cancel. First I'm going to cancel the 5's out. Those are gone. And then I can also cancel the pi's out. But notice over here, I get to cancel pi's on this side also, which is awesome. So what do I have left? I have 100 divided by 5, and that's 20. And over here, all I have is the radius squared. Okay, I'm on the final step. I'm going to take square roots of both sides. That'll give me just a plain radius. And the square root of 20 I can leave as an exact answer. If I want to simplify it, let's just make that radical 4 times radical 5. Radical 4, of course, is 2. So 2 radical 5 if I need an exact answer. Or if I'm just interested in a decimal, I'll just go to my calculator and take the square root of 20. And rounding to the nearest tenth, that's about 4.5. Let me note that that's an about 4.5. So in either case, I have the radius. Don't forget that unit of centimeters, and you've got everything you need.